Our trip down memory lane is going to continue. We are going to take a look at melting, boiling, evaporating, and condensing, and the different phases of matter. Let's just remind ourselves of physical change and chemical change. Physical changes are about energy and states of matter, so solid, liquid, and gas. And we will, if you haven't done your ABBA dancing with me before, we'll get a chance to do that in class. Chemical changes happen on a molecular level. Bonds have to be broken and made in order for chemical change to occur. So, phases of matter. Any substance, almost, under the correct conditions of temperature and pressure, is able to exist as a solid, a liquid, or as a gas. So, water, the obvious example, can exist as ice, water liquid, and water vapor, gas, or sometimes called steam. These three phases of water can be studied quite easily. Why? Because the boiling points and melting points are easy for us to get to. They're quite close together, and we're used to all three phases of matter. Other substances, if you just want to get iron to be a liquid, for example, you'd need to elevate it to some phenomenal temperature, over 3,000 degrees or something, 2,800 I think, and then to get it to be a gas even more. So water is just easy. Other substances often need to be changed to very high or very low temperatures and pressures before you can study them. So oxygen would need to be at like minus 240 in order to be a liquid, and even colder to be a solid. So yeah, water is just convenient. You know that when particles are in a solid, they're close together, they vibrate, and they stay in one position. Liquid, not as orderly as the solid. Spaces between the particles are small, but they are there. And they also vibrate, but they're able to move from around in the liquid. They're not stuck. And in a gas, the particles are far apart, and they vibrate, and they twirl, and they whirl, and they dance, and they've got big spaces between them, and they go quite magoo. They exhibit the most vigorous motion. Why? Because the forces between them are very weak. So, particles of a solid, one spot. Particles of a liquid, close together, but they just wiggle among each other. Particles of gas, far apart, wow, 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 all over the place till they hit the side of the container each time. All particles are moving, though. Even the solid particles are moving. They're just going vibrating. The greater the motion, the higher the temperature. So, what if I increase the temperature? We break out of the lattice and we turn into this. What if I increase your temperature, your movement? Wow! Suddenly you turn into a gas. So the more energy I put in, more heat, the more kinetic energy, movement energy the particles have, the more they can move around and change phase. We've got three different types of motion that we now need to know something about, which suddenly takes us into grade 10 instead of grade 4. Vibrational, translational, and rotational movement. So solids exhibit only vibrational motion. They vibrate in one spot and stay in one place. Liquids and gases have more freedom, and they vibrate. Translate means go from one spot to another, and rotate, they spin around all of the time. Particles are much further apart in gases, though. Solids have the greatest forces between the particles. They get stuck together, very orderly arrangement. We call that a lattice. And the gases have the weakest, almost no forces between their particles. In fact, something called the ideal gas model assumes that there are no forces between the particles of gases. But that's a lie. They're very weak ones. Right, so what is a phase change? So if I heat up some water, I can heat, and suddenly it will get to 100 degrees centigrade. 100. The water would be 100, and so would the steam be 100. They'll have exactly the same temperature. The thermometer stay at a constant 100, and at that stage, all the energy is doing the business of changing the liquid phase into the solid phase. So the energy first heated up the liquid, but when there's a phase change, the temperature itself will stay absolutely constant. So the temperature increases, stays the same until all that water's gone away, and then goes up again. On the other side, so this is the boiling. On the other side, if you happen to have ice cubes in your juice, that means that you have got ice and water coexisting. The whole system must be at 0 degrees centigrade. So this thermometer is measuring the temperature of the water. I suppose we should choose another color. And this thermometer is measuring the temperature of the steam, and they'll have the same reading during a phase change. So what is a phase change in words? Heating solids causes the particles to vibrate faster as the temperature increases. With continued heating, the vibration becomes so vigorous that the particles break free of their lattice. How exciting is that? Out of jail. And they fix positions and the solid melts. That is a phase change. The very fast-moving liquid particles can break free from the liquid and jump out and form a gas. And the liquids are, when they're heated strongly, we call that boiling. Boiling is the phase change that takes place when the bubbles form inside the liquid, because it's not only the particles on the surface that have enough energy to bounce out, lots of particles have enough energy, and if they're in the middle of the liquid, you land up getting bubbles, bloop, bloop, bloop. So, when solids are strongly heated, they melt. It's at a very specific temperature, we call that the melting point, and they form a liquid. The same process occurs for liquids at the boiling point. So solid into liquid is called the melting point. It's a specific temperature for specific substances, and for a liquid, and you know that is 0 degrees for water, and liquid to gas is 100 degrees for water into steam.